Yes, in the last class we discussed about the velocity constant of the first order chemical reaction. There is a K value. K is given by means of 2.303 divided by T log base 10 of R naught divided by R. This is for reactions where we are expressing the concentrations in terms of moles per liter. I suppose gaseous reactants are there. Then you are expressing the concentration in terms of the partial pressures. Then in such cases, how do you calculate the velocity constant of the first order chemical reaction? Now consider a chemical reaction. Consider a chemical reaction. Consider a chemical reaction. Consider a chemical reaction. A plus B, A in gaseous state plus B is also in gaseous state. So A gives rise to B, that is in gaseous state, and C, that is in gaseous state. Where A is the reactant and B and C are the products. Where A is the reactant and B and C are the product. Whereas AG, it is a gaseous reactant. AG is a gaseous reactant. Whereas the B and C are gaseous products. Where B and C are the gaseous products. Now in terms of the gaseous products, concentration is expressed in terms of partial pressures. In gaseous systems, concentration is expressed in terms of partial pressure. 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 Now, initial pressure here corresponds to at T is equal to 0. Now this is partial pressure of A and partial pressure of B is 0 and partial pressure of C is also equal to 0. PA is equal to partial pressure of A. P is equal to partial pressure of A. PB and PC are partial pressure of B and C. Partial pressure of B and C. Whereas the B and C means here B in the form of the gaseous one and C in the form of the gaseous one. That is A in the form of the gaseous one. Initial pressure is given by PA. This is 0 because no products at all formed. And C, no product C is formed at T is equal to 0. Now, pressure at an instant of time t, I will call as this is PT, this is equal to x and this is given by means of the x. This PT is given by means of PA minus x. because X is nothing but the reduced pressure. X is considered as a reduced pressure. Now what is reduced pressure? The part of the reacting molecules of Eg, they react to give the product. Therefore pressure of the system that gradually decreases. Therefore that small decrease in pressure is considered as X. That is, X is the pressure, that is a small decrease in PA. Therefore the pressure at an instant of time t with respect to the reactant A is given by PA minus X, and X corresponds to the partial pressure of the B, and this X corresponds to the partial pressure of the C. Therefore partial pressure of A is given by at an instant of time t PA minus X, and partial pressure of the B at an instant of time t is given by means of X, and partial pressure of C at an instant of time C is given by means of X atmosphere pressure. X atmosphere pressure, this is X atmosphere pressure, this is PA minus X atmosphere pressure. That is in atmosphere pressure, that is in atmosphere pressure. This is in atmosphere pressure, atmosphere pressure. Therefore the total pressure at an at an instant of time t, total pressure at an instant of time t is given by at an instant of time t is given by it's a PT. That PT is equal to, PT is given by means of partial pressure of A plus partial pressure of B plus partial pressure of C according to the Dalton's law of partial pressure. Now what is PA? This is PA. That is a PA minus X. PA minus X. That is PA minus X. What is PB? That is X. What is PC? That is X. This is given by means of PA minus X plus X plus X. Minus X and plus X get cancelled. This is given by means of PA plus X. That is equal to PT. PA minus X is equal to PT. Therefore PT is given by means of PA minus X, PA minus X, or X is equal to PT minus PA. X is equal to PT minus PA. Now PT minus PA. Otherwise I will call this as a P naught values. This is a P naught value, that is initial pressure. This is P naught value, that is an initial pressure. This is P naught value, that is initial pressure. This is P naught value, that is initial pressure. Call this is a P naught value, that is initial pressure. Now this is a PT minus P naught. PT minus P naught. PT minus P naught. Now this is P actually. P. X is equal to PT. No, but at time t, but at time t Pa is equal to P naught minus 6. P naught minus 6. Substitute the values. We know that x is equal to Pt minus P naught. Substitute the values. Therefore, Pa is equal to P naught minus Pt minus P naught. That is equal to P naught minus Pt plus P naught. This is equal to 2 P naught minus Pt. This is Pa. 2 P naught minus P. For a gaseous chemical reactions, K is given by means of 2.303 divided by T, that is log based on what is the P naught divided by Pa. P naught divided by Pa, whereas the P naught is initial pressure and that Pa is a pressure at an instant of time t, is reduced to K is equal to 2.303 divided by T log based on keep P naught as it is. This is Pa is given by means of 2 P naught minus Pt. 2 P naught minus Pt. Substitute these values, we can get this one. This is in terms of partial pressures. No, very important. Very important. K is equal to 2.303 divided by T log based of R naught divided by R. This is for liquid reactions. K is equal to 2.303 divided by T log based of P naught divided by 2 P naught minus 2 P naught minus Pt. This is for gaseous reactions. Second one, this is for liquid reactions. P naught divided by 2 P naught minus Pt. Now try to solve problems based upon Calculate the time in seconds. Calculate the time in seconds for the decomposition of nitrogen pentoxide. For the decomposition of nitrogen pentoxide, which follows first order kinetics. Follows first order kinetics when concentration of N2O5 the concentration of N2O5 is dropped from 0.1 m2 0.01 m. Within bracket K is equal to 6.22 10 to the power of minus 4 per second. 10 to the power of minus 4 per second. Solution. We know that K is equal to (2.303) divided by T log base 10 of R naught divided by R for first order kinetics. For first order kinetics, or T is equal to 2.303 divided by K log base 10 of R naught divided by R naught divided by R, where K is equal to velocity constant of a first order reaction is equal to 6.22 into 10 to the power of minus 4 per second. 6.22 into 10 to the power of minus 4 per second, and R naught is equal to initial concentration of the reactant. Initial concentration of the reactant, that is equal to 0.1 molar. R is equal to concentration at an instant of time. Concentration of the reactant concentration of the reactant at an instant of time t, it is equal to 0.01 molar. T is equal to time taken by the first order reaction. T is equal to time required to bring about concentration from 0.1 molar to 0.01 molar. Now substitute the values properly and simplify. Then T is given by, that is 2.303 divided by 6.22 into 10 to the power of minus 4 to log base 10 of 0.1 divided by 0.01. Simplify. 0.1 divided by 0.01. You know that this is 10. 0.1 divided by 0.01 is equal to 10. For T is equal to 2.303 divided by 6.22 into 10 to the power of minus 4 into log base 10 of 10. You know that log base 10 of 10 is equal to 1. Therefore, T is equal to 2.303 divided by 6.22 into 10 to the power of minus 4, that is into 1. Log 1 is equal to 1. Log 10 is equal to 1. Then substitute these values and simplify. Then T is given by 2.303 into, this is 10 to the power of 4 numerator, divided by 6.22. That is in terms of second you have to calculate. In terms of second, this is 2, that is 10 to the power of 4 multiply, then divided by 6.22. That answer would be 3.7 into 10 to the power of 3. 3.7 into 10 to the power of 3 seconds. 10 to the power of 3 seconds. That is your answer. Problem. %70 of a first order reaction is completed in 23 minutes. Calculate the rate constant of the reaction. Calculate the rate constant of the reaction. Calculate the rate constant of the reaction. Solution. We know that K is equal to 2.303 divided by T log base 10 of R naught divided by R. R naught divided by R. Where not right, what in way from first order kinetics. From first order kinetics, substitute the values where K is equal to velocity constant of the first order reaction that has to be calculated. T is equal to time taken by the first order reaction that is 23 minutes. 23 minutes. R naught is equal to initial concentration of the reactant. Initial concentration of the reactant. That is going to be 100 units. 100 units. Water unit. R is equal to concentration of the reactant at an instant of time t that is given by 100 minus 70 is equal to 30 units because 70% completion, therefore 30% retention. 30% retention. Now substitute the values. For K is equal to 2.303 divided by 23 log base 10 of 100 divided by 30. 100 divided by 30. This is your velocity constant. Now this is given by means of K is equal to 2.303 divided by T log base 10 of 3.333 and so on. 100 by 30 is equal to 10 by 3, that is 3.33. This is 23 minutes. This is 23 minutes. By using your logarithm table, then you substitute the values. Therefore, K is equal to 2.303 divided by 23. This is 3.33. Characteristic is 0. Characteristic is 0.33 at 3, mean difference 3. You from logarithm tables. Characteristic is 0. Characteristic is 0. That is 0.5228. This is 5228. from logbook. This is at 33, this is 3 and this is 3. 0.5228. Now substitute the values. 2.303 into 0.5228 divided by, that is 0.05235. 0.05235. 0.05235. 0.5235 units per minute. Units per minute. Therefore, K is equal to 0.05235. That is in terms of, supposing here in terms of minute they used to put per minute, in terms of second put per second, in terms of year it is a put per year, and so on. Okay. Problem. %50 of a first order reaction . 50% of a first order reaction is completed in 40 minutes. Calculate the time required to complete. Calculate the time required to complete. Calculate the time required to complete. 65% of reaction. 65% of reaction. 65% of a reaction. This is first order reaction problem. First order reaction problem. Here we make it two problems. In first problem, this R value is given as R0 minus 50%. Calculate the K value. By using the K, you substitute in the second problem, then you calculate the time required for 65% completion of the chemical reaction. Make it two problem. In first problem, for 50% completion of the chemical reaction, calculate the K value. K value. We know that. R0 divided by R. R0 divided by R. Now we substitute the values where k is equal to velocity constant of the reaction for 50% completion. For 50% completion, call this as a K1, make it as 2 problem. For 50% completion. For 50% completion. This is for 50%. For 50% completion. And K2 is equal to same 2.303 divided by T 65% log base 10 of R naught divided by this R 65%. R 65%. This is for 65% completion of the reaction. This is for 65% completion of the reaction. Since it is a first order reaction, K1 value is equal to K2 value. Since it is a first order reaction, yesterday we discussed the K value is found to be constant at instant of time t. K1 is equal to K2. K1 is equal to K2. Since LHS is equal to RHS, therefore 2.303 divided by T 50%, that is into log base 10 of R naught divided by R 50%, that is equal to 2.303 divided by T 65% into log base 10 of R naught divided by R 65%. R naught divided by R 65%. Okay. Now simplify. R naught is equal to initial concentration of the reactant. Initial concentration of the reactant. Initial concentration of the reactant, that is 100 units. 100 units. R 50%. That is equal to concentration of the reactant. Concentration of the reactant left after minutes. That is equal to 100 minus 50, that is equal to 50 units. R 65% is equal to concentration of the reactant. Concentration of the reactant left after T65. After T65. That is 100 minus 65, that is 35 unit. 35 unit. That is a T50 is equal to time required to reduce 50% of the concentration. 50% of the concentration. That is already mentioned. That is in terms of 40 minutes. Substitute the values. That is a 2.303 divided by 40 into log base 10 of 100 by 50. That is equal to 2.303 divided by T65 log base 10 of 100 minus 35. 100 minus 35. Here this is 2.303 get cancelled. This is 1 by 40 into log 2. That is equal to 1 divided by T65% into log 100 by 35. 100 divided by 35. 100 divided by 35. Calculate. And divided by 35. That is 2.857. That is 2.857. 2.857. Now the calculate the T65 value. That's all. Calculate T65 value. One by 40 into log 2 is equal to 0.3010. That is equal to 1 divided by T65% into log 2.85. It is given by 0.4559. 0.4559. Log 2 is equal to 0.3010. Log 2/7 is equal to 0.4559. Now substitute the values. This is 0.3010 divided by 40 is equal to 0.4559 divided by T65%. Therefore, T65% is equal to 0.4559 into 40 divided by 0.3010. Simplify, its value is found to be 60.586. 60.586 minutes. This is nothing but time required to complete 65% of the chemical reaction. 65% of the chemical reaction. Is it clear? This is how to calculate the problems of the first order chemical reaction. Thank you.